Hey there, welcome back to our channel, where we uncover the secrets of space. Today, we have an intriguing question that, can we blow bubbles in space? Well, get ready to be amazed because we have the answer for you. So, let's get started. In the vast expanse of space, numerous mysteries and curiosities await exploration. One intriguing question that arises is whether it is possible to blow bubbles in the absence of gravity. In this video, we will delve into the realm of space and investigate the feasibility of this fascinating phenomenon. Humans have always been captivated by the allure of bubbles. Whether it is blowing bubbles as children or observing the shimmering spheres floating effortlessly in the air, bubbles have a certain enchantment. As we venture beyond the Earth's atmosphere, the question arises, can we recreate this captivating phenomenon in space? Number 1. The science of bubbles. Before we explore the possibilities in space, let's briefly understand the science behind bubbles. Bubbles are thin films of liquid enclosing air or other gases. They form due to the surface tension of the liquid, which pulls the liquid molecules together, creating a spherical shape. The air trapped inside the bubble exerts pressure, allowing the bubble to retain its form. Number 2. The role of gravity. Gravity plays a crucial role in bubble formation on Earth. When we blow bubbles, gravity pulls them downward, and the air inside the bubble rises to the top. The combination of gravity and surface tension helps maintain the shape of the bubble and keeps it from floating away. Number 3. Environmental factors in space. In the microgravity environment of space, the absence of gravity significantly affects the behavior of fluids. Without the downward pull of gravity, liquids tend to form spherical shapes naturally. This behavior is observed in free-floating water droplets aboard the International Space Station, ISS, and other space missions. Number 4. The challenges of blowing bubbles in space. Blowing bubbles in space presents unique challenges. Firstly, without gravity to pull the liquid downward, it becomes difficult to create a bubble by blowing air into a liquid. The lack of buoyancy also affects the stability and longevity of the bubble. Secondly, the absence of air pressure in the vacuum of space poses another hurdle. On Earth, the higher air pressure outside the bubble keeps it intact. In space, the absence of pressure differential makes it challenging to maintain the bubble structure. Number 5. Potential solutions and experiments. Despite the challenges, scientists and astronauts have conducted experiments to explore the behavior of bubbles in microgravity. These experiments aim to understand the fundamental physics behind bubble formation and test various techniques to create and control bubbles in space. One approach involves using a soap solution that contains a surfactant, a substance that reduces the surface tension of water. This technique helps stabilize the bubble structure and improve its longevity in microgravity environments. Number 6. Implications for science and technology. Studying bubbles in space has broader implications for scientific research and technological advancements. The behavior of fluids in microgravity provides valuable insights into various natural processes and industrial applications, such as fuel systems, water management, and drug delivery systems. Understanding the dynamics of bubbles in space can lead to advancements in materials science, fluid dynamics, and aerospace engineering. It can also contribute to the development of innovative technologies for space exploration and colonization. Number 7. The beauty of bubbles in space. Apart from the scientific significance, bubbles in space possess an inherent beauty. The sight of shimmering spheres floating gracefully, unaffected by gravity, evokes a sense of wonder and awe. Images and videos of bubbles in microgravity captivate our imagination and remind us of the boundless wonders of the universe. Number 8. Future possibilities in research. As space exploration continues to expand, so will our knowledge of bubbles in microgravity. Future missions and experiments aboard the ISS and other space stations will shed further light on the behavior and potential applications of bubbles in space. Researchers will continue to explore innovative techniques to create stable and long-lasting bubbles in microgravity environments. These efforts will contribute to our understanding of fluid dynamics, materials science, and the possibilities of sustaining life beyond Earth. In conclusion, while blowing bubbles in space presents challenges due to the absence of gravity and air pressure differentials, ongoing research and experiments offer promising avenues for exploration. The behavior of bubbles in microgravity provides insights into fundamental physics and has potential applications in various fields. Moreover, the visual spectacle of bubbles gracefully floating in space reminds us of the wonders and mysteries that await us in the cosmic expanse. Here are some simple questions and their short answers. First, can bubbles exist in the vacuum of space? Yes, bubbles can exist in the vacuum of space. While the absence of air pressure makes it challenging to create and maintain bubbles, scientists have developed techniques using surfactants to stabilize and control bubbles in microgravity. Second, how do bubbles behave in space? In the microgravity environment of space, bubbles tend to form spherical shapes naturally due to the absence of gravity. However, without the downward pull of gravity and air pressure differentials, creating and maintaining stable bubbles in space is a complex task. Third, what are the implications of studying bubbles in space? Studying bubbles in space has implications for various scientific and technological fields. It provides insights into fluid dynamics, material science, and the development of advanced technologies for space exploration and applications on Earth. Fourth, are there any ongoing experiments related to bubbles in space? Yes, scientists and astronauts continue to conduct experiments aboard the ISS and other space missions to explore the behavior of bubbles in microgravity. These experiments aim to improve our understanding of bubble formation, stability, and potential applications. Fifth, can bubbles in space be used for practical purposes? The study of bubbles in space has practical applications in areas such as fuel systems, water management, and drug delivery systems. Understanding the behavior of bubbles in microgravity can lead to advancements in these fields and contribute to space exploration endeavors. In this video, we have explored the intriguing question of blowing bubbles in space. Although it presents challenges, ongoing research and experiments offer exciting possibilities for understanding the behavior of bubbles in microgravity environments. The beauty and scientific significance of bubbles in space continue to captivate our imagination and inspire future exploration. If you have found this video informative, so don't forget to hit that subscribe button and turn on notifications so you never miss a fascinating science update. Thanks for watching, and stay tuned for more amazing discoveries.